In this video, I'll be showing you how to use the Normalcdf and inverse normal functions on the calculator. These are the 6.2 notes, page 4. You can see that they're already annotated with the calculator function and the results in the notes, but in this video I'll show you how to actually use those functions, how to decide what numbers to put in and where into those functions. So this example is about a pediatric research study that examined the heights of 3-year-old girls. So our population is 3-year-old girls, the variable is heights, and we're told that it has a normal distribution, and we're given the mean and the standard deviation. In any normal distribution problem, I always begin by sketching a bell curve. And I've done that here on the left side, and the first thing I do is I locate the mean immediately in the center of the distribution. So in this case, the mean is 38.7 inches, so I put 38.7 at the center of my bell curve. Now I look at my question. It says, what proportion of 3-year-old girls are shorter than 36 inches tall? So I look at 36 inches, that's a height. I put it on my x-axis below 38.7. And since the question says what proportion are shorter than 36 inches tall, that means I'm going to shade to the left, because shorter than 36 inches tall means below 36, so that's to the left of 36 on my x-axis. Now, anytime you want to find an unknown area under the curve, and areas under the curve give you proportions or probabilities, you use Normalcdf. So let's bring our calculator up. Here's our calculator, and to get to the Normalcdf, I have to press the second key and then the vars key. Above the vars key it says DISTR. That stands for distribution or probability distributions. So this is what I see when I press the second key, then the vars key. And the one I want is number 2, Normalcdf. So I choose number 2, Normalcdf. Now let's go back to our picture. Normalcdf requires 4 entries. The first entry is the left end of the area I'm looking for, and the second entry is the right end of the area I'm looking for. Now this area extends to the left. Remember, the normal curve extends infinitely in both directions. So in reality, the left end, there is no left end to the area. It extends to negative infinity. Since I can't enter negative infinity on the calculator, I enter in a very large negative number. I frequently enter in negative and then do several 9s in a row. This is usually fine. Some other people do it differently, and if you have a way that you prefer to do it, that's fine. Then I enter in the upper end of my area, and if you look here, the upper end is 36 of my shaded area. The upper end of my shaded area is 36, so I enter in 36 and then another comma. And then the last 2 numbers are my mean and my standard deviation. So my mean in this problem is 38.7 inches. That's given to me. And my standard deviation, this is my mean, 38.7. And my standard deviation is also given to me. That's 3.2. And I close my parentheses, although that's not entirely necessary for this function, and I hit enter, and I get 0.1994045.072. Given that the normal distribution is an approximation, it's just a model, it makes no sense to write down all of that. I usually round my probabilities to 3 decimal places. So in this case, if I'm looking for the proportion of 3-year-old girls who are shorter than 36 inches tall, I put 0.199, or if I want to give it as a percent, I say 19.9%. So roughly 1 in 5 3-year-old girls is shorter than 36 inches tall. Okay. Recall, the next example says, what's the probability that one 3-year-old girl selected at random is shorter than 36 inches tall? Areas under the normal curve can correspond to either a proportion of the population or a probability for one randomly selected individual from the population. So the proportion and the probability are exactly the same. Let's look at the next example. It says, let x be the height of a randomly selected 3-year-old girl. Find p parentheses 36 less than x less than 42. Well, first I need to understand what this thing in the parentheses tells me. And what it's saying, if x is the height of a randomly selected 3-year-old girl, it means the probability that the height of a randomly selected 3-year-old girl is between 36 and 42 inches tall. Okay, you see the entries over there on the right hand side. So again, let's look over here. I drew my normal curve, put 38.7 in the middle. 36 is below the mean, so I marked it to the left of the mean. 42 is above the mean, I marked it to the right of the mean. And I shaded in between because I'm curious about the probability that the height is in between 36 and 42 inches tall. So my normal CDF uses my left end of my area, which is 36, the right end of my area, which is 42, and then the mean and the standard deviation. So if I bring my calculator up again, and I go to my normal CDF, and I would do 36, 42, 38.7, 3.2. And hit enter, and I get 0.649. So 0.649, or a little bit less than 2/3. So that's the probability that a randomly selected 3-year-old girl would be between 36 and 42 inches tall. Now, what about the inverse normal? So as this says, another question we can ask is how tall a girl must be to be in the top 10%. So if you're in the top 10%, that means you're pretty tall. So again, like every problem, I draw my bell curve, put my mean in the middle. So I shade some area to the right, and I say that's the top 10%. Well, I don't know what the height is, so I put an X down below the x-axis. But I do know that the top 10% corresponds to an area of 0.1 or 0.10. This is different than the last problem. In the last problem, I was trying to find a shaded area based on x values or heights. Now I know the shaded area, and I want to know the height that forms the boundary of that shaded area. So basically, this is backwards of the problem I was doing before, so I'm going to do inverse normal. It's located in the same place, second in the variables key, but this time it's choice number 3. The first entry is the area to the left of the point you're looking for. So I'm looking for the minimum height associated with the top 10%. Well, the top 10%, the area below that would be 90%, since 90% plus 100% is plus 90% plus 10% is 100%. So the area then would be 0.90 to correspond to 90%. So I put in 0.9 as my first entry, and then the mean and the standard deviation. So the inverse normal only uses 3 entries instead of 4 entries. And I get a result of 42.8. Now, be careful. The answer to this question is not 42.8. The question is, how tall does a girl have to be in the top 10%? Well, 42.8 is just a number. I need to give it its units to give it context, so 42.8 inches. And she doesn't have to be exactly that tall. She has to be at least 42.8 inches tall. So the correct answer to this question is a girl must be at least 42.8 inches tall to be in the top 10% by height. Now let's go back 1 second to my second bar's distribution menu. And you'll notice there's one thing with the normal that we didn't use, and that's Normalcdf. For our class, we don't ever use that function. So don't ever use Normalcdf. We use Normalcdf to find areas under the curve based on x values. We use inverse normal to find x values based on areas under the curve. So if you are given values of your variable, like heights in this case, you use and asked about probabilities or proportions, you use Normalcdf. If you are given a percentage or perhaps a probability, and you want to know the value of your variable, like we wanted to know the height in the second example, you use inverse normal. Going back to the notes, the next question says, what's the first quartile? We have to remember back to Module 2 that the first quartile bounds the lower 25%, which is why in this problem I did inverse normal, 0.25, comma, and then the mean and standard deviation. So I hope this gives you a little insight in how to use the Normalcdf and the inverse normal. The only thing I'll leave you with is that it actually is okay in certain instances to leave off the mean and standard deviation, and that's if you're working with z-scores. Because the z-scores are part of the standard normal distribution, which has a mean of 0 and a standard deviation of 1. If you don't include the mean and standard deviation, the calculator automatically assumes you're working with z-scores. If you have any questions, please feel free to drop me an email, and I'll do my best to help you understand how to use your calculator in this way.